Let's start our chemistry class. And this is our 5th class on solid state. Hope you are aware of the previous topics. Let me go with the next part of it, the ionic lattices. And we'll take up the ionic crystals today. Hope Aditi, you were there in the previous classes, or at least you would have seen it from the previous lectures. Shall we go about with the ionic lattices? Fine, let me take up. See, what is the basic difference between, if I take a metallic crystal, all the lattice points will be made up of only one type of atoms. Like let me take aluminium, sodium, or the magnesium metal crystal. If I take, all the lattice points will be made up of only one particular atom. But if we go for an ionic compound, it will be made up of, like let me say sodium chloride. Either the lattice points or the voids will be occupied. Like if sodium ions form the close packed structure, the voids will be occupied by chloride. Or if chloride forms the close packed structure, sodium ions will occupy the void. Generally, the voids are occupied by a smaller ion, because when we take a cation and an anion, the smaller ion generally occupies the voids. So today let's see how the ionic compounds are arranged in the crystal structure. So we'll go about the sodium chloride structure, which we call it as a rock salt. We'll also go with cesium chloride structure, the body centered, and then we'll also talk about the zinc sulfide and all other structures. We'll take few ionic compounds and then do it. Fine. How do we know approximately what would be the crystal structure? What we try to take is the radius ratios. Generally, when we take the ratio of radius, it will be ratio of cation to radius of anion. Generally, the radius ratio is taken as the smaller ion to the larger ion. Generally, the smaller ion would be the cation, so we take it as radius of cation to radius of anion. So these radius will be constant. Based on the values, we can say whether the coordination number is 2, 3, 4 and so on. And how do we go with the coordination number? What is coordination number? We discussed about it. The number of nearest, because we are talking about ionic compounds, it is the number of nearest oppositely charged ions. Sorry. Nearest oppositely charged ions. So if I go with coordination number of 6 for sodium chloride, it means that around sodium there are 6 chloride ions, and each chloride ion once again is surrounded by 6 sodium ions. So based on the coordination number, we can go with the structure. How do we get the coordination number? Based on the radius ratio, and these are some constant values. We also call it as limiting radius ratio, because this is the maximum value that it can have. So if the radius ratio lies within 0.225, the coordination number will be either 2 or 3. It might change from 2 to 3. That is, for some ion it will be 2, for the other ion it will be 3. So in case if the coordination number is 2, it would have a linear shape, some part of it is related to the chemical bonding of your first year. And if the coordination number is 3, it would be a triangular shape. The example that we can take is boron oxide. So if the limiting radius or the radius ratio is 0.225, the coordination number will vary from 2 to 3. Our concentration for the competitive exams will be these 3. Though this might be asked, but let's concentrate on these 3 because it's more of sodium chloride, cesium chloride that has been paid more of concentration along with the zinc sulfide which has a sphelerite structure. Fine. If the radius ratio lies between 0.225 to 0.414, the coordination number would be 4. What does coordination number 4 mean? The cation is surrounded by 4 anions or an anion is surrounded by 4 cations. Like let me take zinc sulfide. Each zinc ion is surrounded by 4 sulfide ions. Each sulfide ion again is surrounded by 4 zinc ions. So we say the coordination number is 4. Hope you are able to understand. Any doubt, just stop me. 4, coordination number 4 means the oppositely charged ions around it are 4. And what would be the structure? It is known again as tetrahedral. The example, the crystal structure, we call it as zinc sulfide or sphelerite structure. The examples that we can take along with zinc sulfide, you will also have copper halides, mercury sulfide and barium sulfide as examples. Then the most known one is the radius ratio between 0.414 to 0.732. The coordination number we give it as 6. When the coordination number is 6, we take it as octahedral. If the coordination number is 4, it would be a square planar structure. 6 is what we take it generally for sodium chloride. And 4, we call the structure as octahedral. If it is 4, it will be square planar. We call the crystal structure as NaCl type or rock salt type. And what other examples that we can take is magnesium oxide, sodium bromide along with sodium chloride, calcium oxide, silver chloride and so on. If it is 0.732 or more, generally it's given as 1. The coordination number is 8. The shape will be cubic and we call the crystal structure as cesium chloride type structure. Because why do we name it as cesium chloride or sodium chloride type? Because we take that as a standard example. The other examples could be the cesium halides, ammonium bromide. These values you will have to remember along with the coordination numbers. It's easier to know. Sometimes the questions can be framed based on the coordination number. Now, the positions are also equally important for us. If I take NaCl, I also said NaCl we also call it as rock salt type structure. Where are the cations present? At octahedral voids. Where are the octahedral voids present? At body center. Where are the octahedral voids present? They are present at body center and the edge centers. Yes. All cations are present at octahedral voids while the anions are making up the closed pack structure. So what is the crystal type? We call it as face-centered cubic crystalline structure because we also have the lattice points at the center of the faces. So anions would be present at corners and face centered. So we say the crystal lattice as FCC. Where are the cations present? They are present at body center and the edge center. What's the coordination number in 6? What do we mean by 6? Each sodium ion is surrounded by 6 chloride ions. Nearest are 6 chloride ions. By the same way, each chloride ion is again surrounded by 6 sodium ion. Alti and Maithili, Priyarda, are you able to understand? Then if we go for cesium chloride, because it's some part of it is interrelated to our previous topics. Cesium chloride type is body centered. We have called it as BCC crystal structure. And where are the cations present at the center of the body? And anions would be simple cubic unit cell, in the sense they are present at the corners. Where are the anions present? They are present at the corners. And how many corners are there? 8. And each cesium ion is surrounded by 8 chloride ions, or each chloride ion is surrounded by 8 cesium ions. So we give the coordination number for both as 8 and 8. Sometimes it so happens the coordination number is not same. But in case of sodium chloride and cesium chloride, the coordination numbers are same. Zinc sulfide is called as sphelerite type of structure. They are present at, cation is present at alternate tetrahedral walls. If you can recollect our previous topic, Maithili, you were asking me about the questions. Now here also we will calculate. If sulfide ions is making up complete closed structure and zinc ions are occupying alternate, in the sense half of the tetrahedral voids, what should be the formula of the compound? Number of closed packed to tetrahedral voids is 1:2. But only half is occupied, so it will be 1. So the sulfide ions and the zinc ions are in the ratio of 1:1. So we get the formula as ZnS. Are you able to understand how we are getting the formula as ZnS? Anyhow, we'll also see in the next of the PPTs how to calculate all this. I'm just going with this so that you understand right away. But tetrahedral voids enga irukum? If you take a phase diagonal, what happens at exactly 1/4 distance from the corner? If you take a phase diagonal, this one, no, let me not show it that way. We will take up the crystal structure in the slides and then try to see where the tetrahedral voids are present. Tetrahedral voids will be present exactly at 1/4 distance from the corner. Then if I go with the calcium fluoride, we should get the formula as 1:2. When will we get the formula as 1:2? If one is forming the closed packed structure, the other is occupying all the tetrahedral. Aditi, we have the ratio. If n number of closed packed structures are formed, the number of tetrahedral voids that will be formed in a crystal lattice will be 2n. So the number of tetrahedral voids we have, that's what I'm telling you, that only. Okay, fine. I'll do it there now. See, we have a ratio of CCP, closed packed structure, is to tetrahedral voids, is to octahedral voids. If you take any crystal lattice, there will be n number of close packed structures formed. The number of tetrahedral voids will be 2n, and octahedral voids will also be equal to n. And it's not necessary that all the voids will be occupied. It depends on the size of the ions to either occupy tetrahedral or an octahedral void. So if I take zinc sulfide structure, what is given? The cations will occupy alternate tetrahedral voids. What do they mean by alternate tetrahedral voids? If there are 8 tetrahedral voids, only 4 will be filled up. So only half is filled. So if half of 2n will become n. Yes, Aditi, it will become n if it is half of tetrahedral voids, and the closed packed structure again is n. So sulfide ion and zinc ion will be in the ratio of 1:1. Got it, ma? So it will be in the ratio of 1:1. If all the tetrahedral voids are occupied, the example that we are going to do next, you will understand if all the tetrahedral voids are occupied, what should be the formula. Let me keep this here and then take up the next one, which is that cation is occupying alternate body center. In calcium fluoride, alternate body center, and that of anion is occupying all the corners. That is, it is forming a simple cubic cell. Unit cell. Here when we took cesium, here all body centers are occupied, so we are getting a coordination number of 8:8. Here it is only alternate, and it is again reduced by half. Cubic closed pack will remain same. Cubic closed pack will be only n. When I am talking about the complete crystal lattice, wherein the tetrahedral voids are double the number. Here they have given only tetrahedral voids are changed, but not this one. You will understand more clearly once we go with the video, or let me say animated pictures. Just hold on till there. I'll also show along with the structure. You will be able to understand it better. Is it okay, Aditi? Shall I continue and then we'll go with the crystal structures? You'll understand it better. Okay, let me take this. It's simpler here. Sodium oxide anti-fluoride structure, all tetrahedral sites are filled up. So if sodium ion, all tetrahedral sites are filled up, and the oxide ions are forming the closed pack structures. How many tetrahedral voids are there? 2. So sodium will be double the number of the oxide ions. We get the formula as Na2O. If it is only half, we get the ratio of 1:1. So sodium oxide anti-fluoride structure, the cations will occupy all the tetrahedral sites, while the oxide ions will form the FCC unit cell. So what will happen to the coordination number? There will be 4 oxide ions surrounding the sodium ions, but each oxide ion will be surrounded by 8 sodium ions. Shall I continue? Artha side polama. Fine. It's very clearly shown the positions of everything. The sodium chloride structure is composed of sodium ions and chloride ions. The number of sodium ions is equal to that of the chloride ions, because we are getting the ratio as 1:1. Let's also see how we are getting the ratio as 1:1. The radius of sodium and chloride ions are given as 95 and 181. We are getting the radius as 0.524. So this lies between 0.414 to 0.732. This radius ratio that we are getting is 0.524 lies between இதுக்கு நடுவுல இருக்கும் எதுக்கு நடுவுல 0.414 to 0.732. So coordination number எவ்வளவு வருமா நமக்கு 6, giving the radius ratio. Okay, chloride ions are arranged in cubic closed packing. In this arrangement, chloride ions are present at the corners. What are the corners? These are the chloride ions. These are the corners. And the center. This is the center, I can say, if we take it this way. When visualization, it will be little confusing if you take the complete. If you take a unit cell, what a unit cell number clear. Here you'll have a little confusion about which is face center and which is the corner. So corner level 8 lattice points at corner, shared by 8 other unit cells. So the number of lattice points at corner is 1. There are 6 faces shared again by 2 unit cells, so it will be 3. So chloride ions வந்து நமக்கு 4 வரும். Sodium ions எங்க இருக்கும்? It will be at body center. Body center எவ்வளவு lattice points இருக்குமா? Only 1 இருக்கும். There will be only 1 because it's not shared by anything. Then இன்னும் எங்க இருக்கும்? Edge centerல இருக்கும். எவ்வளவு edge centers இருக்கு நமக்கு? 12. I meant in the unit cell there are 12 edge centers shared by how many unit cell? 4 unit cell. Contribution எவ்வளவு இருக்கும் நமக்கு? 3 வரும். 1 plus 3 is 4. நமக்கு sodium ions 4 and chloride ions 4 இருக்கு. So sodium ions is to chloride ions நமக்கு 4 is to 4, because we are getting it as 4 is to 4, we can write it as 1 is to 1. So we write the formula as NaCl. The same calculation, let's see here. Here the ratio வந்து நமக்கு 1 is to 1 இருக்கிறதுனால we are writing the formula as NaCl. Clear இருக்குல்லமா? It's simple, very simple. The only thing is you will have to see the positions and then go for the calculation. Since there are 6 octahedral holes around each chloride ion is surrounded by 6. Again the coordination number, whatever we have learnt in tabular column, we are trying to analyze it. This is called as 6 is to 6 coordination. In a sodium ion is surrounded by 6 chloride ion, the same thing. Each chloride ion is surrounded by 6 sodium ions. Fine. Whatever calculations I showed you, the same thing which has come here. Has 4 sodium ions and 4 chloride ions as calculated. 12 at the edge center. இது வந்து என்ன octahedral void. And 1 at the body center. Again, it's not shared by any other. That's what I said. This will be 4 sodium ions and the 4 chloride ions. Number of chloride ions on the 8 at the corner, shared equally by 8 other unit cells. 6 at the face centers, shared equally by 2 unit cells. So inga 1 plus 3 namukku evaru varudhu 4. Because the ratio is 4 is to 4, we will take it as 1 is to 1. Most of the halides of alkali metals, oxides and sulfides of alkaline earth metals have this type of structures. And what structure? Rock salt type of structure or NaCl type of structure. The other example that you will go is sodium iodide, potassium chloride, rubidium iodide, rubidium fluoride, ammonium chloride, ferrous oxide. Ferrous oxide formula என்னமா? Ferrous வந்து Fe plus 2, oxide வந்து O minus 2. So what should be the formula? FeO is ferrous oxide. Again we are getting the formula as 1:1. Has sodium chloride type structure in which oxide ions are arranged in CCP. CCP, and we had a CCP, it will be corners and face centers. And Fe plus ions occupy octahedral voids. If it is octahedral voids, it will be body centered and edge center. Hope you are able to understand. Let me go for the next slide. Fine, cesium chloride. Simpler, we can see, I mean, a unit cell is directly taken. This is one ion. What ion is that? Cesium. The green ones are the chloride ions. You get the radius ratio as 0.93. 0.93 na coordination number enna varnum? Yes, what should be the coordination number? This is lying above 0.732. So what should be the coordination number? It should be 8. 8 and நமக்கு body centered cubic crystal lattice varum. And what does this 8 mean? Here if you take one unit cell, you can see, because it's only one taken, if you take further, it's not 4, it's 8. Eight, 0.732 and more, it should be 8. When will you get 4? When it is between 0.225 to 0.414. You can easily see each cesium ion is surrounded by 8 chloride ions. So coordination number, if you can take up the 3-dimensional structure, you can also see how each chloride ion is also surrounded by 8 cesium ions. Now how do we take the ratios? 1:1. Chloride ion is present at corner. There are 8 corners in a unit cell shared by 8 other unit cells. So the effective number of atoms or ions at corner will be 1. Cesium ion is present at body center. There is only one body center for a unit cell, not shared by any other unit cell, so 1. So cesium ion is to chloride ion, we are getting it as 1:1. So formula we will write it as CsCl. So the chloride ion from the simple cubic arrangement and the cesium ions occupy cubic interstitial holes. In other words, chloride ions are the corners of the cube, whereas cesium ion at the center of the cube. I was telling you the same thing. Hope you understand. Shall we go to the next slide? Coordination number of each ion is 8. So how do we know the coordination number? From radius ratio. When do we get the coordination number as 8? When the ratio generally lies between 0.732 to higher value, generally we take it as 1, or anything higher than that, we will get the coordination number as 8. See, if there is no problem and exactly the cesium ion, if it has to fit into the void space formed, should be equal to 0.732, it will fit perfectly, but Since the size of the cation is little slighter, what happens? It goes beyond 0.732, it is found to be 0.93. So what happens? The anions move little away from each other to accommodate the cesium ion. I was telling you this calculation. Hope you understand that. The effective number of atoms per unit cell of cesium effective number of what do I have? Formula units. What is formula unit? One formula. Cesium chloride is one formula. For cesium chloride would be equal to 1. In case of sodium chloride, I can say it as 4 because we are getting exactly 4 sodium ions and 4 chloride ions. Ratio we are taking it as 1:1. But the effective number of sodium chloride units per unit cell will become 4. For cesium chloride it is 1. For sodium chloride, I am just trying to make you understand the difference so that it will become easier for you to study. Any doubt? Shall I continue? We have done this already. See, this is one type of ion. What is this ion? The chloride ion. This is chloride ion. This is cesium ion. Where is it present? At the body center. And where are the chloride ions present? At corners. This is what is called as body diagonal. What is body diagonal? Made up of 2 anions and diameter of a cation. 2 chloride ions plus 2 cesium ions together. I am taking the diameter which will make up root 3a. That's what we have taken. If you remember, 4r is becoming root 3a. But here, if I take the radius, I will take radius of cesium ion plus the radius of chloride ion. Chloride ion is equal to root 3a by 2. I am talking about an edge length here. So radius of cation plus the radius of the chloride ion is equal to root 3a is the edge length. It's by 2. Because this 4 is nothing but 2 radius of cations to 2 radius of anions. That is 2 RCS plus 2 Cl minus is making up root 3a. I can write 2, I can take it as common. Cesium ion plus the chloride ions is equal to root 3a. What should I write for cesium ion to chloride ion? Root 3a by 2. Are you able to understand how we are getting this? Fine, we'll do this question. If the ionic radius of cesium and chloride ions are 181 picometers and 161 picometers, if both the units are same and even the options are of same units, let's not go for conversion. Conversion paname calculation panla. What do we have the formula? Radius of cesium ion plus the radius of chloride ion will be equal to root 3a by 2. And what is asked? Edge length of the unit cell is asked. So A is equal to 2 radius of cesium ion. Okay, let me write this. Radius of cesium ion plus radius of chloride ion by root 3. How much is this? 181 plus 167 into 2. What is root 3? 1.732. Calculate பண்ணலாம் எவ்வளோ வரும் 181 plus 167 how much is it? $348 into 696 divided by 1.732 வந்து எவ்வளோ வருமா? Which should be the option? You get 401.84 varum picometers. Approximately we can make it to 402 picometers. Is the calculation clear? Maitri and Aditi, are the calculations clear for this? Shall I continue? You get the answer as 402 picometers. Magnesium oxide has a rock salt type structure. Good. Ionic radius of magnesium and oxide ions are 86 picometers. So in case of a rock salt structure, we have lattice points at the corner. We also have a lattice point at the corners and the edges. So we can directly get an edge length A 2 into radius of cation plus radius of anion is equal to edge length whenever we have a rock salt type structure. We don't need to take a phase diagonal. We can directly take edge length is made up of 2 radius of cations and 2 radius of anions will be equal to A. So radius of cation எவ்வளவு கொடுத்திருக்காங்க 86 plus anion on the 126 is equal to the edge length. Again they asked us the edge length. Why did we take root 3a in case of cesium chloride, and why is that I am directly taking this? Because if you go with a body centered crystal lattice or cesium chloride, we get cesium and chloride ions only along the body. I mean these are at the corners. நடுவுல மட்டும்தான் cesium ion இருக்கும். If I go with the rock salt structure, here I'll get an edge which is made up of 2 chloride ions and 1 cesium. So I can take this edge length itself. Hope you understand that why I am taking the calculation over here as 2 radius of cations and anions is equal to edge length. How much will that be? 86 plus 126 is 212. 2 times 212 would be 424 picometers. Let's see if the answer is right. Yes, the answer is 424 picometers. Is the calculation clear? Good. Fine. Let's go with the zinc sulfide structure. Look at the structure very clearly here. The zinc sulfide will also go with a video with the 3-dimensional structures of all these. But now you just understand the zinc sulfide crystals are composed of equal number of zinc ions and sulfide ions. The radius of 2 ions, zinc ion is 74, okay. We are getting it as 0.40. So what should be the coordination number? What should be the coordination number? Fine, see, zinc ion is 74, sulfide ion is 184. You're getting the radius ratio as 0.4, which suggests a tetrahedral arrangement. 4, very good. That's 4 because the radius ratio lies very much less than 0.414. So we will take the coordination number as 4. So the yellow ones, the sulfide ions, you can see the size of the sulfide ions is bigger. It can also be known from its ionic radius, which is given as 184, and these are the zinc ions, which are very small. You can see the position of the sulfide ions. They are forming the closed packed structures, while the zinc ions are occupying the voids. Where are they found? At corners and the face center. These are present in alternate tetrahedral voids. Can you see the diagram? Very good. Between 4 and 6. Lower side would be 4, higher side would be 6. Is the structure clear? Structural part of it. Okay, let's take the zinc sulfide structure once again. Zinc ions, I was telling you, they occupy the tetrahedral hole. Only half of the tetrahedral holes are occupied by zinc, so that the formula of the zinc sulfide, I was telling you right in the beginning itself when the tabular column was given, it will become 1:1. See, when it was in lower classes, you used crisscross method to find out the formula of the compounds. Here, we are trying to get the formula of the compound based on their crystal structures. These are your sulfide, though here it's given big, it's only for you to understand. These are the tetrahedral voids wherein the zinc ions are present. These are the sulfide ions. Again, the coordination number, as you are saying, it's 4, 4:4. For exact fitting of zinc ions in the tetrahedral voids form, the ratio should be exactly 0.225. But since the ratio we are getting is slightly bigger, as we spoke in terms of sodium chloride, it will be slightly distorted, little distortion, because zinc ions is trying to push the sulfide ions away because its radius ratio is little more. Okay, let's see how we are getting zinc ions are present at tetrahedral voids, while sulfide ions are present at corners 8 into 1 by 8 plus present at faces 6 into half. So total is 4. Out of the 8 tetrahedral voids, it's only occupying half, so it's 4 tetrahedral voids. Other examples with the zinc blend structure is CuCl, CuBr, CuI, Ag, and beryllium sulfide, BeS. We also have another structure called as zinc sulfide Woodside structure. It's a hexagonal closed pack structure. Can you visualize it? You can see the void clearly shown. This is occupying, these are the closed packed structures, though they are kept separately, so it's making up a tetrahedron, if you can see that. And the void here is filled up with another ion. The same thing over here, just try to visualize the structure. I know it's difficult, but for now just understand it. We'll try take a three-dimensional structure. Let me say a video on that also. See, complete solid state depends on your visualization. The other calculation part is very, very simple. Look at this now. The wood-side structure, such a beautiful way of animation created by the concept tree people. Your chemistry coordinator was doing it very well. You understand that? Fine, let's proceed. So when the coordination number, even the same thing we discussed last time, more the coordination number, more is the interaction, greater is the stability. Which has higher coordination number? Cesium chloride. Then we have taken NaCl. Then comes your zinc sulfide, sodium oxide. Zinc sulfide we can take spherulize and wood-side structure. Then comes all your rest of the compounds. So when the coordination number is more would be the interaction between the oppositely charged ions, and there would be an extra stability. So when we increase the temperature, the coordination decreases. That is, a compound which has a higher coordination number like 8:8, what happens when we try to heat it? It will change its coordination number. It changes to a lower coordination number of 6:6. So when we increase the temperature, there would be a change in the coordination number of the crystal structure. Pressure, the other way around. So increase in temperature lowers the coordination number. Increase in pressure increases the coordination. Any doubts so far? Shall we continue? Fine. Let's take the fluoride structure, calcium fluoride. The calcium ions are arranged in the CCP structure. You can see they are present at the corners, very clearly shown. Yes, you have. This is the phase center. These are the corners. And where are the fluoride ions occupied? They are occupying all the tetrahedral holes. The fluoride ions are occupying all the tetrahedral holes. Since the ratio of the closed pack structures used to tetrahedral voids is 1:2, which is forming the closed pack is the calcium ions. Each calcium ion will be surrounded by 8 fluoride ions, while one fluoride ion will be surrounded by 4 calcium ions. The coordination number in such cases will only be different, but what we have seen till now is NaCl, cesium chloride and zinc sulfide. The coordination number was same, either 6:6, 8:8, 4:4. The coordination number was constant, but in calcium fluoride, which we call it as fluoride structure. The coordination number is different for each ion because calcium ion is surrounded by a larger number of fluoride ions. How many? 8 fluoride ions, because calcium ions is forming a closed packed structure. In case of sodium oxide that we will see next, we call it as an anti-fluoride structure. A little difference in the arrangement. The cations and anions will vary in their arrangement. That's the only difference that you can see. You are able to understand, right, why we are getting a different coordination number. Fine, let's take up this one. It was a video made. I don't know why it's not coming now. It was such a beautiful video that was made. I did try and then see that also. Maybe it was not saved. Fine. Calcium fluoride. The same thing what I was trying to explain was given. This is the ratio of 1:2 because we are getting 4:8. It will be 1:2. Each calcium ion is surrounded by 8 fluoride ions and each fluoride ion is surrounded by 4 calcium ions. So the coordination number will change. In anti-fluoride, as I was saying, you can take lithium oxide, you can take sodium oxide. A little difference from what we have seen. In calcium fluoride, calcium is occupying or forming the CCP, fluorides the tetrahedral voids. In anti-fluoride, it's reverse. Whatever we are getting it as 2 will be the tetrahedral voids. Whatever we are getting it as 1 will be the closed packed structures. The oxide ions constitute a cubic closed packed structure and lithium ions occupy all the tetrahedral voids. You are able to understand the difference between how we have got it for fluoride and anti-fluoride structure, how we are writing the formula? Clear the mind. How we are getting it as the reverse formula. Here what is there? Oxide ions are forming the closed packed structures. So the number will be 4. Lithium ions are occupying all the tetrahedral voids 8. So ratio on the 1:2. What is 2 is lithium. So lithium oxide. Same you can take for sodium oxide also. We call it as anti-fluoride because it is quite opposite. Fluoride structure is opposite. So we call it as an anti-fluoride structure. Let me see if I can share that. I don't know what happened to this video. Just hold on. I'll just try it in some other way. I'll just open it again. Because there's a video for this also. Fine. You can see if you are able to see that. Good. So beautifully you can see the arrangement. So you can see the ones at the corner, now itself it is shared into half, when shared into four pieces when you cut it into half. It means that it is equally shared by 8 unit cells. You can see that cross on the corner lattice point, the mustard yellow color one. Can you visualize the zinc sulfide structure, Maithili and Aditi? How is it becoming one lattice point? Close pack structures எவ்வளவு வரணும் நமக்கு 4. You should get 4:4. We got 4 ions of one type, 4 ions would be of other type. Right? Understood? Let me go for the other one, which we missed. Fine. Check this. Such a beautiful one, fluoride structure. Is it changing or is it stuck again? Let's try once more because it's given so lovely. The different fluoride structures. Oh, I don't know why the video is not playing. It has become more of a PPT type. Okay, now it's playing. The difference between what we have seen in sphalerite and this is in sphalerite, not all the tetrahedral voids are occupied. Here, all the tetrahedral voids are occupied. So we should get closed pack structures of 4. The lattice points in the voids, we should get it as 8. Practice the questions and I'll also tell you where exactly you find the questions. Meanwhile, you just keep looking at how we are getting the structure. Done? Is it clear? We shall wind up. Hope you could see very clearly that the number of lattice points in the tetrahedral voids you are getting it as 8, and that of the closed pack structures we are getting it as 4. Fine, just do practice from your books. You would also have it in the complete course. I meant all the review questions and all practice questions are added in that. Thank you, ma'am. Questions, 1 minute. I'll tell you where it will be given. One minute. Give me a minute, I'll just tell you. See, they are uploading DPP's daily practice paper in main NEET course. So probably you would be getting it. That's what I was told. We'll just do once. After tomorrow's class, I'll just give you a few more questions in the class itself. Okay? And from now on, you will have one practice sheet for every topic that is done. Okay, ma? Thank you.